So now, continuing with the parts, you just recall, see what is basically the wave radar. So we started with the new technology of the millimeter wave radar to sense the things. To basically, what type of sense? For example, when we are using basically automatic vehicle, right? Automatic driver assistant system, ADA, or sometimes it is a advanced driver assistance system. So what does it do? See, car is automatically operated. Some object is in front. You are able to see whether car has to stop, whether car has to slow down. When some mark is there, so car can take a turn. So these type of things are there. They are the very important application of wave radar is there. So see definitely the question arises, see whatever we are using, why can't we use a camera? But as we discussed in the morning, see the camera has a limitation. Camera has a limitation that it requires the light, right? Another limitation, it depends upon the weather. For example, basically in the fog and the snowy weather, then light is automatically, surrounding light is very lower. In the dark, it is very less likely to work. In that case, we have seen that all weather option is our wave radar. Despite it, another things also, many times the security, your privacy is the issue. And see, for example, I don't want that my data needs to be uploaded somewhere. I'm not interested in disclosing my data, sharing my data. In that case, also the wave radar is very useful option. Why? Because if you would have seen here that there are basically uh, what is generated, it is basically the 3D point cloud. Some points are generated which in correspondence to the presence of the object. What do we do? Because we want to process it smoothly, we basically convert that 3D point cloud into a 2D point cloud. And once it is there, it is exactly like the thing that, for example, we have colored basically, we have converted the colored image into a grayscale image. So that's we are doing. Apart from it, we have we applied this thing to detect the in-vehicle occupancy, how many persons are there at the back of the seat, which seat is occupied, for example, and how many persons are there, and which places are they occupying. So these different type of informations are able easily extracted with the help of the wave radar. So can we just so and thereafter, see, remember, whatever we are doing, these algorithms are not only to basically test the thing, but we also want to implement these things in the form of the hardware. So in that direction, we take a basically pink JDU based implementation. This what is this pink JDU implementation? That is basically on the, see, those people who are working in the VLSI, there is a VSDL, Verilog hardware description language. There the things are implemented in the that language, hardware description language. But here, PingZU allows you to transfer your program from Python, and you can run the hardware without changing into a uh, Verilog language. So that actually encouraged us to use the this PingZU because most of the times, see, it is not necessary that you have the same exposure to the VSDL. So that doesn't deteriorate you from using it. So this is the you would be. And this is, and yes, also we also discuss basically the wavelet function. See, in signal processing, as we have seen it, when we look for the time frequency based features, then wavelet seems to be the most appropriate. What is so when we say basically the Mexican head wavelet, Mexican head is basically the shape of the shape of the, we say that the principal function or the basis function which we are using to represent. So you can take the different type of bases. If you would have, while seeing the MATLAB and the Python, you would have realized that you can apply the Morse, Mayer, and R wavelet. So these again see, without going into their mathematics detail, capture the time frequency information together. Now we continuing with the next part. So what we are doing when we are see after the road boundary detection, please be clear in that context what we are seeing, that we are basically seeing that can our how can our automatic vehicle go ahead. In that context, boundary is important. Now, in our detection, now we move forward. MM-wave radar detects the, how is it done? It detects the radiations from road surface discontinuity, guardrails, right? You would have seen it there. It detects and elevated structures to infer road boundary. What is the role of the road boundary? That there it has to keep the vehicle within that limit. The radar point cloud data can be converted into 2D top view images for easier feature extraction and classification. Algorithms like modified NSEC and Kalman filters help fit curves or lines to radar data to estimate road boundaries. Even see these algorithms are very useful when many things together. Combining radar data with camera images. See, it doesn't mean that you don't have to use camera. Definitely only what we are telling that yes, camera, it can be a very good option. But yes, if we have the provision to use a camera, then it enhances detection accuracy through multi-sensor data fusion. Real-time implementation is possible on embedded platforms like FPGA for application intelligent vehicles and construction machinery. Challenges include low resolution of radar data, presence of noise and clutter, and variability in road types and boundary structure. Remember, so that's why we are using the filter. And remember, road types, what we are saying, see, many times at the crossings, it seems that it's a boundary. But then it is not a boundary. Road boundary detection helps. What does it help? It basically improves vehicle localization. It reduces lane departure risk. Because when you are going into a highway, when your automatic vehicles are going, then definitely it should be in a same lane and enables safer autonomous navigation in unstructured environment. So this is motivation regarding or doing these things. Limitation of vision-based method. traditional camera-based detection systems are highly sensitive to environmental conditions such as low light, fog, or rain, leading to reduced reliability in world scenario. Advantage of radar, it offers robustness against advanced environmental factors, making it a more suitable sensor modality for consistent, accurate road boundary detection. There is a need for effective data representation to efficiently utilize radar data. A top view filtration technique is introduced, which transforms 3D point cloud data into 2D representation. What does it do? This basically simplifies the data while preserving essential spatial features necessary for boundary analysis. What is the GSP? Again, do you think it can we apply the GSP here? No, then fine. Good. So regarding it, what we are saying that in GSP, this is basically first we apply the graph Fourier transform for extracting complex structural feature from radar images, enabling more accurate and robust road boundary detection, as well as it is a real-time hardware implementation, validate the feasibility of the proposed approach in real-world embedded systems. The entire detection pipeline is implemented on an FPGA-based Pink JDU platform, ensuring low latency and energy efficient operation suitable for autonomous vehicles. What is the hardware? You can see it here that the hardware setup we did it for the data collection. The radar was mounted on a tripod at a height of approximately 80 to 100 centimeter above the ground for data collection. The experiment was conducted at a distance of 3-4 meters from both the left and right sides of the road center. 4 scenarios were considered for road boundary detection. So, what were the things? Case 1, it is guardrails on both sides. You can, including those constructed from grass, were used to recognize the boundary. Another case 2, a single guardrail on one side was used to recognize the boundary. In case 3, boundary. So, see, please, okay. Now is it visible? Actually, what happens when I come for the basically chat session, then I have to reshare it. Only I was seeing that very limited participants are there. So what is the what you are seeing here? That the 4 scenarios are there for considerable road boundary detection. In first case, the guardrails are there on both the sides, including those constructed from the grass, were used to recognize the boundary. A single guardrail on one side that also was used to recognize the boundary. The third case, it is the boundary identification was conducted at a merge point. So, and in the case 4, boundary detection was attempted without any guardrail. So, these samples were basically collected across the 4 cases. We are 840 samples. In the case where both the guardrails were there, one guardrail, it is 740 samples. In the boundary identification at a merge point, there is 460 samples. And then the remaining samples we took up where boundary detection was attempted without any guardrail. Distribution of samples is shown here. (3D) point cloud generation and processing using wave radar and the ROS. So what we are doing here, initial that we saw it that 3D point cloud images were generated from raw radar data for each experimental case. In the hardware and system setup, the wave radar uses basically Texas instrument. This one which code number is AWR1843 designed for radar imaging of application. In the radar parameter, the options available were maximum detectable range, pulse setting, range resolution, and frequency range. So they were configured using either radar graphical user interface or custom configuration file. During the data transmission and integration, real-time data transmission was established using communication interfaces such as USB, UART, or Ethernet. Radar was connected to a ROS-compatible system. What is basically ROS? ROS is basically a software which allows you to fetch that data from the radar. In the data processing, utilized ROS specific drivers like the ROS driver to process raw incoming radar data, extract key attributes. Basically, all these are available. That range is there, azimut, what angle it is there, elevation, and velocity. And you drive out 3D spatial coordinates of detected objects from processed data. Under the visualization, we used this one, a ROS visualization tool, RVIL, to display the 3D point cloud. Significance of 3D point cloud, they are chosen for the road boundary detection and DAS applications because, so what is the significance? They are basically chosen for the boundary detection and ADAS application, advanced driver, because they offer direct spatial information, enable efficient object detection and classification. They integrate well with machine learning and graph signal processing technique. So overall, see 3D point cloud generation air comparison series the time frequency analysis by joint time frequency analysis is valuable for Doppler and motion detection. It lacks it is both the way it is useful that the Doppler and motion detection. However, it lacks spatial awareness, making it less suited for tasks like road boundary detection. Top view filtration for 2D conversion. 3D point cloud data was transformed into 2D representation using a top view filtration technique. This method projects 3D data onto the XY plane, effectively removing Z information, as we have already seen it in the morning, retains the horizontal spatial distribution of objects, enables clearer visualization and easier analysis, especially for distant object detection. So that experimental setup you are seeing that where the real images of boundaries were taken. What you are seeing here that this is the case where both here you are seeing able to see the boundary. This is basically at the one circle. This is another case where only one side guardrail is there. And this is where they are meeting at a point. So when you are seeing here, this is a 3D point cloud image. So different cases, your S1, S2, S3, S4, you are generating it. here in what is the limitation here? The deep neural networks are effective for 2D geometric problems. However, they struggle with point cloud data, especially on radar measurements, due to irregularity and sparsity of the data, lack of uniform structure, unlike grid-based image data, high spatial variability which compared with traditional 2D signal processing. See, high spatial variability basically, what we are saying here, that is, since it's not a this is when many points are there, there need to be some fixed background. But see, that is not there, so it is not that easy to extract the feature from the 2D signal processing. Inadequacy of traditional techniques. Grid-based methods are ineffective for radar point clouds due to their non-Euclidean nature. These methods assume structured layout which radar point clouds do not follow. Whenever if there is a structured layout, our algorithm is far able to process that layout into a some category. What did we do basically when these problems were there? We applied that this structure part can be taken care in the form of the weight. If we can somehow define the some weight, and then it will automatically come to, we find it GSP useful here. It allows the modeling of point clouds as graph where nodes represent points and edge capture relationship. What is the advantage of GSP based framework? We directly extract discriminative features from the graph topology. Avoids reliance on restrictive grid-based assumptions because as when the graph topology is available, so there and it effectively handles a regular spatial distribution in radar data. See why it is able to handle? Because see that information of irregularity is captured in form of the weight metric. It achieves a higher classification accuracy than conventional signal processing or DNA methods. See, so regarding the classification models, in classification model, as we have seen it, that we have used basically, again, we are using the some particular machine learning model because we are very able to tune their parameters. And we are also we are getting the very, very good result. What is it showing here that the same model support vector machine random forest decision tree logistic regression and KNN will be. So why we are using basically these simpler models over the complex models? One thing is basically that simple models offer faster inference. Even they are actually less time taking. Another is basically hardware constraint that these models are lightweight and can be easily implemented on resource constrained platforms like FPGA. Model simplicity, and interpretability. It is easier to understand, debug, and validate. So it is crucial for safety critical systems. Data characteristic. The nature of the radar-based point cloud data is well suited for classical ML models without requiring deep temporal modeling. And definitely, see, we are not compromising the computational efficiency in addition to the energy consumption. So that also real-time road object. In the real-time road object also we apply the ping JDU. Ping JDU, what it be is consider it is the same thing. It is an advanced version of ping Z2. Same thing as we have mentioned, it is quad core ARM Cortex versus for general purpose computing that has been there. In the another thing, it is dedicated ARM Cortex R5 core. Again, these are the some hardware part which we are emphasizing that how it is better. Even see FPGA enhancement is there in the form of that it has 5.7 times more DSP slices, 8 times greater block RAM capacity. These enhancements enable significantly better hardware acceleration. Heterogeneous design benefits, it supports true parallel processing of computationally intensive workload. Ideal for MMW radar signal processing algorithms requiring high throughput and real-time response. So, any question if you have? So regarding the deployment and performance, complete system successfully deployed on pin JDU. So here if you see, there see how this is basically connected. JDU, it's a lab setup, we have connected it. What they are doing basically here the software, the whatever program is there, you port it on this board, JDU board, and then it is run and then you are able to check out. So hardware, software, co-design features supports accelerator, coherent support, and advanced memory hierarchy, enables efficient parallel execution or radar signal processing and object classification tasks, ensure deterministic response times via dedicated real-time processor, provides efficient hardware acceleration for computed-heavy algorithms. That is being shown here as mentioned. So this is the workflow or the road boundary detection. So what is there? See, you have how many have seen the earlier also road boundary detection? Can GSP implement? Yes, the GSP application, yes, we have it has been implemented. Whatever your program, Python program is there, you can directly run it there. And you can also check out that how much time is it taking to run. We have the real-time idea. Even see the hardware realization is also very important part of the research. It has been implemented. So again, see, if you would have noticed that, see, earlier the road boundary detection had been implemented, but here we are also implementing with the hardware analysis. So again, see, we use the same board, pink JDU board, and there we found out its performance. What is its performance? Here, if you see, this is confusion matrix. So in confusion matrix, these four type of road boundary detection are there. in this road boundary detection. This is, so can somebody tell what is this 101? This again here 101. Is it possible or is it by mistake? Yes, it is compatible with SDL, very much compatible. Only advantage is that here that your language Python you can directly it converts into SDL. My question is there you are seeing basically one confusion matrix. Is it possible what they are showing 100, 100, 191 or is it by mistake? Actually, I have to come back to the screen because I am not able to see both the things together. To see what you are seeing here and to remove the mystery, remember 101 are the total cases are there, right? This is not basically the percentage. This is the total case which they are considered. Percent, it is not basically the percent. It is not necessary either. You can take the total number of cases or the percent. Both the options are available. So this is basically the results. What we are showing the result here, that the accuracy or the GWT model and the GFT model. So conclusion and future work here, accurate road boundary detection among basically the four categories essential for both autonomous and human-driven vehicles as they define the permissible driving area and ensure safe navigation. This importance is heightened in adverse weather conditions where visibility is compromised. Achieving full autonomy in all weather scenarios requires robust road boundary identification. This study proposes a multimodal approach that combines machine learning techniques with wave radar for fetching road boundaries under diverse weather conditions. So this approach uses graph wavelet transform and random forest algorithms for feature extraction from 2D top viewpoint cloud image. This system achieved a peak accuracy of 95% in road boundary detection, which is a fair one. The important thing, what you are seeing here, those people who are doing the research, first time it is, we are basically defining the road boundary. You can see the work here, you can, comparison work is, comparison. Okay. See, let me explain. See, I am seeing this as a confusion metric. So what we are saying here, you see it again. We should see, for example, see, we go to the for confusion metric. This is first we need what is this S1, S2, S3. It was a 90 can. 90, 40, so 4 units. It's just 2. See, first we need to understand what is this S1. S1 is basically guardrails on both sides. including those constructed from graph. Yadi aap see, are you able to see? This is basically the case where on both the side boundaries there. A single guardrail on one side was used to recognize the boundaries. For example, it is only this side that is also visible. Boundary identification was conducted at a merge point. So, see, here you can see it. Boundary detection was attempted without any guardrail. So, this is the case when both are merging actually, right? When something is merging. These are the four cases, S1, S2, S3, S. So, when we come to the confusion matrix, in confusion matrix, see, what we are saying that when we randomly see checkout, so what we are seeing that 90 cases were there when it was found satisfactorily correct way. In one case, it was found as the S2. S1 is identified as the S2. In this case, it was identified as the S3. Here, what you are seeing in the three cases, S2 is identified as the S1. 101 times it is satisfied as this one. So what we are saying, it is not the percentage. It is not always the percentage. You can take both the percentage, even you can take the cases also. Here what has been done? Here we have taken the cases, right? We have taken the cases in the S2. How many cases we have considered? 101 plus 7, 108 cases. Here how many cases we have considered? 99 cases. Here we have considered basically 104 cases. Here we have considered the 94 cases. So that's why it is saying it is the true level. So what was the true level? When S2 was exposed, it was S1. Here it was S2. Here it was S3. In case of the S3, it was 0 times recognized as the S4. So this is does it answer your question? Someone, does it answer your question? Actually, I have to stop the slide because I can't see both the chats and share slides together. What we are saying here that it is not only the always percentage, it is the number of cases also. So you don't need to confuse that it is 101%. It doesn't violate it. In place of value percentage, yes, it can be written. Yes, that is also there. But see, sometimes what happens if you write percentage, it is 99.856 this value. So it is in 0.1. So that's why we prefer to write it in that. Even see, you can point out also any gaps in the result. So it will be helpful, or if we are not correct somewhere, it will feel free. To conclude, and future work, accurate broad boundary detection is essential for both autonomous and human-driven vehicles, as it defines the permissible driving area and ensures safe navigation. This importance becomes very crucial in adverse weather conditions. Why? Because see, when it is a road boundary, when you are seeing the hilly regions, when the vehicle is going, then it becomes really very difficult. Then you have to maintain your vehicle in a same lane. Because if somehow you cross the lane, then it is likely to be life threatening. Not only this, but also at the highway, for example, at the national highways, this is also becomes very important. Even your maximum accidents can be controlled if the vehicles are in the proper lane. They are not abruptly changing the lane. Achieving full autonomy in all weather scenarios require robust road boundary identification. This study proposes a multimodal approach that combines machine learning techniques with mmWave radar for detecting road boundaries under diverse weather conditions. This approach uses graph wavelet transform and random forest algorithm for feature extraction from 2D top viewpoint cloud images. So here 95% is detected. This future work, we can improve the framework by addressing class imbalance in the four class boundary classification problem. Further optimizing the FPGA-based real-time detection system, it integrates MM radar and graph signal processing for advanced driver assistance system. Now see, we come to the point, another of our hand-related activities, gesture recognition. So that is also used. What type of gesture? Can you see the figure? Yes. You are seeing this figure. So I should maximize. Hmm. So are you able to see the images? These images that we want to remember, not only at a big object level, but also we are able to differentiate the change in the gestures. Whether it is the hand away, whether it is the arm moving to the left, whether the arm moving to the right, whether hand away, hand closer, palm up, palm down, right? It is actually when you are seeing the G6 image, it is not very clearly visible. It is G7, it is hand to the left, it is G8, hand to the right, G9, closing fist horizontally that you are seeing here, and it is closing fist vertically. What is the difference here? Difference here, it is horizontally, here there is a base, and there it is a base, right? That's why the direction is shown here. In horizontal, it is this. So what we are seeing, see, it is not only able to MMA radar, it is not able to differentiate the big vehicles, but also the small change. That has been demonstrated here. So static hand gesture recognition refers to identifying hand poses that do not involve movement, such as fist, open palm, or thumbs up. Dynamic hand gesture recognition involves detecting a sequence of hand movements over time, like waving, sweeping, or drawing a shape in the air. Gesture recognition, so what is going to serve purpose? It basically enables intuitive and natural human-machine interaction without voice or touch input. It is useful in scenarios like driving, medical environments, smart homes, and this is augmented reality where touch or voice may not be feasible. It helps improve accessibility for individuals with speech or mobility impairments by providing alternative input methods. So it enables basically contactless interaction, which enhances hygiene, convenience, and safety. Thank you for your patience. This was some network problem. That's why you need to keep it hold.
Yes.
See you.
What do you say? नहीं हो रहा है क्या? नहीं हो रहा तो क्या प्रॉब्लम नेटवर्क?
Am I audible? Am I audible?
मेरा भी नेट चला गया. यस, इसने बोला.
Thank you. I don't know why I am unable to share the presentation. Please have the PPT is there, even I am selecting it, but it is not shared. That's the problem coming.
Stop
Stop the offering.
Stop sharing.
Thank you for your patience. There was some network problem. So see, is screen, is it visible? So I am showing basically dynamic and static hand gesture recognition.
Yes.
So see, what is the key thing here? Dynamic hand gesture recognition. It is detecting a sequence of hand movements over time. And in static hand gesture, it is identifying hand pulls that do not involve movement, right? That's why we have differentiated it. So what is its basically main role? It helps improve accessibility for individuals with a speech or mobility impairment by providing alternative input methods. See, so it helps to those people having the speech impairment problem or mobility impairment problem. It enables contactless interaction, which enhances hygiene, convenience, and safety. What is the problem with the traditional sensor? In traditional sensor, if you see that the RGB cameras fail in low light or dark environment, right? As we have already seen it, it requires cameras are affected by shadows, skin tone variations, and changing lighting. In the background, see if the light is changing, then also it becomes the problem. Background clutter and object occlusion reduce accuracy. The object may be occluded by the presence of the other objects. Privacy concerns, as we have already seen it, due to the capturing visual images, depth sensors struggle with reflective or transparent surfaces. Depth sensors perform poorly in bright outdoor light, right? Depth sensors where you are able to know that at what level it is there. Wearable sensors require users to wear devices which is uncomfortable and not practical. Wearables have issues like battery life and maintenance. So that's why MMU radar seems to be the better option. As it has been shown, it works reliably irrespective of the lighting conditions. It is not affected by the skin color, shadow, or lighting variations. It can detect hand gesture even in cluttered or partially obstructed environments. It doesn't capture visual images. So user privacy doesn't come into picture. Operates well in outdoor and indoor conditions unaffected by light or reflection issues. Provide contactless interaction. No need for users to wear or touch anything. Because radar, it is basically the wave, EM wave, which is sent back and which is reflected back. Detects even subtle finger movements through micro Doppler effect. See, because your hand is moving, you are able to check out. Compact and low power, suitable for embedded systems and real-time applications. So this has been shown here. So in the dynamic implemented SM data sets, right? So see, my one question is there. When your hand is static, how the wave radar is able to identify? The dynamic something when something is moving, then definitely it is going to capture. But when something is constant, will it give the provide the correct information? Would you like to answer? See, I'm saying that when hand is constant, right? When something is moving, then definitely radar is going to work. But when something is constant, will it work? And if it will work, how will it work? See, take your time. So till then we implemented Till then, we check with the dynamic gesture. What is happening in dynamic gesture? So what we are saying that the person 1 and person 2, both their gestures are seen. See why we have taken the two people. We have taken the two people so that at least there is no any individual biasing, right? To increase the number of cases. In the case of gesture 2, it is G2, 1% 75, 105. Then it is the G3, it is 95, 105, and G4, it is so and so. So in this way, we have taken the total number of gestures 1790. In the case of static, we took basically again we took up the 2%. See, more the person you say that the more is basically you are likely to uh, minimize the any biasing error or random by the randomization. So here in static implemented it is feast, palm, finger, shape, and YOLO the sign. It is thumbs up and perpendicular. These signs have been generated in this. Now what we are saying that the work, how is the gesture recognition? What is the workflow? It is I see gestures are there. And are you aware that how much should be the range of the wave radar when you are taking the gesture?
Sir, 100 meter maximum.
Are you aware, see how much is the range?
Approximate 100.
So I will ask Anand to basically respond. Anand is today is with me. Anand, yes, can you like to? What are the Anand will also discuss what are the difficulties when we use the wave radar, when we keep the objects in the vicinity. He is the most experienced person in case of wave radar who has worked.
So hello everyone. So the range of millimeter wave radar is about approximate 100 meter, and the application are on the wave radar. We have conducted like object detection, gesture recognition, human activity recognition, and many more like facial expression. So in this application, we have detect the dynamic and static gesture of hand, in which I will share some presentation slides. So this is the flow chart of hand gesture recognition, in which we have first we have take the data like gesture, different type of gesture, static, dynamic, and then we have convert binary form into the 3D point cloud. Then we have process by using top view filtration. This is the data processing. Then we have split the data into two parts, 80 to 20 ratio. Then we have we have give the data into machine learning, then classify the different classify the gesture which are like uh, dynamic or static, fist, palm, finger, C-shape, YOLO. This is the static, and also recognize the dynamic like arm to left, arm to right, and hand away. hand closer, palm up, and these are the different type of gesture we have classified in this experiment. And we have performed also on the hardware platform like PingJDU. This is the very important hardware to validate our experiment. And this is the result of static and dynamic hand gestures. Like we have performed 7 gestures in static, and in dynamic we have taken 12 gestures to 10 to 12 gestures, and we have achieved the accuracy of 89 for 12 gesture, and for 10 gesture 91 accuracy has been achieved using random forest. And in static, highest accuracy is achieved 95 using 5 gestures, and 92 using 7 gestures. So in this way we have experimented this research. And so next sir will proceed.
So see, this is the one range where as Anand has explained it, that within basically 100 meters you are able to detect it. And see, the beautiful part of radar is that within a short time you are able to generate a data based upon your this sampling rate. With a sampling rate you are able to, and that this is very good thing. That's why I'm saying that if you have the chance to work in the lab upon this type of devices, or if you have the chance to purchase these type of devices, it's a really a very good tool. So as you are seeing it, see, we started with basically this thing, and you see within this is basically our initial work, and Anand was he we obtained very good result, that we are getting this much accuracy. And only thing is basically what has really made a difference, that yes, that we generated our data. That was the key thing. Because in these papers, see, everything is there, but we are not able to generate the data. But only the step which allows us to reach here, that how did we generate the data, and then we thereafter we applied our techniques and extracted the feature, and thereafter applied the machine learning. See, I think hardly there is any paper which is from the India. All papers are from the outside India. See, that is the beauty, that we must able to take the new devices which are available in the market where we can sense the thing. Even see in the biomedicals also, the major, even when Suman is doing research, my another friend Ram Nivas is doing research, what we are see stuck within biomedical, actually these ethical issues are there. So it is not easy to get the permission. Otherwise, see, for the every researcher they are doing, see, please try to have the own data where you have your own observations. Unfortunately, due to the lack of the data, we are simply seeing one parameter, that is accuracy 98, 99, but that has no more any realistic meaning except the paper publication. Because see, you are not able to connect the minor things, minor observation, new observations. We are not sensitive to them, because it is the again the public data, and very limited information is available. That's why, see, on a being a DSP platform, I will say, convey to everyone, see, try to have your own data. Even see the accuracy is coming lower, that's not a problem. But you are able to see the new dimensionalities. You are able to see the new dimensionalities when you apply your techniques, it cultivates the interest. So that is the thing. So now we have come to the human activity recognition, and human activity recognition involves identifying and creating human movements such as walking, sitting, falling, standing, waving. See, remember such a beautiful thing that we started from the mmWave radar to basically initial our application was the different type of car classification, and now we are coming to the human activity. But nobody has answered me that what is the basis when there is no movement? Can really the radar work? Still, I am stuck with that question. So we take up a one break, a small break, and I hope you would come up with the answer. You you will come up with the answer that how is the radar actually working with a static object. And there also we will also discuss see how see today we are only focusing upon the techniques only, but I am telling you data generation, new data generation, that is also the key thing. If you are able to generate it, it definitely provide you a new dimension to your research. So meet it at 4:30, right? We will, but with one question that how is the MMA radar working even when our objective is static? So coming back, Suzy, I share you the answer. Is anyone has come up with answer? See, I tell you the answer that even see the object is static. Even the object is static, definitely, uh, but it is able to detect the shape because it is sending the radiations at the different level. So the amount of radiation which is reflected back, they are able to detect the shape of the object. So range is definitely an extra measure which is detected by the MMB radar, but apart from it, it is also able to detect the overall shape of the object. So is it clear? When somebody asks you next time this question, you would able to respond, you would able to answer it. I hope see all are with me. My questions are like really. So yes, if you agree. Dr. Ritesh, Gloria, Ranjal, Ruchi, Shashikala, Snehal, Sujal. I hope person would be there. I think right. So yes, somebody has responded. AM Shah, yes, at least you are there. Instead, some person, at least one person is there. In the online, it is very, sometimes it becomes advantage, sometimes it becomes disadvantage that it's limited to human machine interaction only. So now, coming to the part, human activity recognition involves identifying and interpreting human movements such as. So as we started from this basically initial object identification to the human activity recognition, that's a interesting thing we observed it. So what is the thing in the human activity recognition with MM-wave radar? It operates in all lighting and weather conditions, including complete darkness or smoke-filled environment. It preserves the privacy by capturing only motion and distance data. Can penetrate clothing and light obstructions, enabling detection of micro movements like hand motions or breathing. See, that is also the even our one of the team in the AMU, they are working to detect the breathing rate. For example, when the person comes in emergency, necessary vitals are to be measured. So, but can we do it without using the instrument? There also the people are using the MM-wave radar. It is robust to environmental clutter and can distinguish multiple moving subjects via range Doppler and micro Doppler analysis. Again, the same thing, see via Doppler, you are able to measure the range, capable of real-time detection with low power and compact hardware integration. It is ideal for continuous, unobtrusive monitoring. It is effective in both indoor. Indoor means in a room also you can detect in outdoor scenarios where lighting condition, etc., noise, etc., will really not make a difference. making it suitable for a wide range of real-world deployment. So this is the beautiful thing. Now coming to the experimental setup. Before, so what we are doing, see, this is a scenario where we are taking, see, what we are doing it here, see, as we are focusing upon the human activity, right? So in human activity, we are a distinctive radar system deployed on a rooftop utilizes mm wave sensors to monitor physical activity. Whether the person is sitting, it is connected via USB to a computer. The radar is positioned on a tripod approximately 3 to 4 feet above the ground and powered by 5-volt power supply. During testing, the user conducted activities roughly 4 meters away from the radar, and the resulting radar data was saved by computer in binary format. To enhance distance precision, the radar operates within the 77 to 81 gigahertz frequency band, employing 2 transmit and 4 receive antennas. See, that's why we are saying it, not only transmitting, but the receiving antennas are there to have the much more sensitivity of the shape as well as the speed. So that's how you are able to understand the significance of this architecture. In the data collection, see what type of, see here basically we are doing the 5 type of activities. One is basically dumbbell, another is squat, another boxing, triceps, walking. In this basically data collection, we have 2 volunteers, one of whom is the first author, who is Anand only. More than 1,500 data sets have been collected by using wave radar as shown in the table. Initially, 3D point cloud pictures were created from the raw data. 3D point cloud as it is basically the first initial picture. After that, features are extracted from 3D point cloud images using the top view filter. Filtered images have been shown in those figures. Here they are using basically the dumbbell, here they are using a squat, here they are using tricep, here they are using basically boxing, here they are using walking. So that way these many samples were taken. Data pre-processing. So initially raw data for each human activity was used to generate 3D point cloud images. So what you are seeing here is a 3D point cloud, and then what we are doing is converting into a 2D point. When you are converting into a 2D point, you are that Z dimension that you are neglecting. So when the top view, it is, so this is in figure 3, it is shown here. Top view filtration simplifies 3D radar data by projecting it onto the XY plane, as we are told in it. Creates a 2D representation that retains the spatial distribution of activities in the horizontal plane. What is the advantage? It is visualization and analysis, spatial distinguishing movement postures and movement patterns. It is useful in human activity recognition, as fall detection, gesture recognition, behavior monitoring. In healthcare, smart homes and surveillance system where fast and reliable identification of human motion is essential. So that is basically the part of pre-processing that we are going through these activities. And machine learning model have been used with decision trees, random forest to identify different fitness activities. As we have already seen, like earlier, the logistic regression model has proven very accurate one. So as we discussed, basically, as we took up the 15, 16 samples were gathered and divided among the 5 categories. So can you guess do we need to take the exactly what was the ratio? Ratio was basically the same one. It was around the 300 on as we have taken it. Why? Because see again, as in the to have the balance, to balance in the your data observation. So this is the thing here. So this is basically the results in discussion that you can see here. That it is a dumbbell activities. You here it is precision is there. Here your accuracy is there. That when you are taking into the 5 activity, so this is 81%. So this is the using with the different classifiers. You can see it here. Here what is visible that in comparison to the deep learning, the result is uh, lower in one of the case. And that is obviously actually. You really see here when you are using CNN plus LSTM, when you are using CNN along with this, definitely with that small data, your accuracy is not coming very high. So the conclusion basically this presents a novel approach utilizing MM-wave radar sensor combined with the machine learning algorithm to develop a non-contact real-time fitness tracker. Unlike deep learning models, machine learning models require smaller data sets and process data more rapidly, rendering them well suited for enhancing the system practical setting. Proposed method demonstrates impressive accuracy while incurring minimal computational overhead. By obviating the necessity for wearing or positioning devices on the body for indoor fitness monitoring, this system presents a superior alternative to existing model. So whether it is the indoor monitoring, outdoor monitoring, that works very well. Now, see, this is a work which we are right now going to focus upon in the near future. This is basically the facial expression detection. And the facial expression, see, even my one of the work, even my base work, my thesis work is in the facial expression, but that is using basically the images, right? Using the image, when you have the image, then you can, from that image, you can convert them into a graph signal, and after converting into a graph signal, then you apply the algorithm to extract out the feature, and after extracting out the feature, then you train it with some machine learning algorithm, and then you are at the end you are able to evaluate your algorithm that how much correctly is it detecting the facial expression. So when it comes, so whenever we are saying basically human emotion, so it is basically more or the less on the maximum database is 90 to 95%. It is the six type of emotions: happiness, sadness, anger, surprise, disgust, neutrality. It plays a key role in emotion aware systems, human computer interaction. See how much is basically the human satisfied when it is interacting with some machine. So if facial expressions are the visible sign to get the feedback. Driver monitoring whether the driver uh, is in the right state to drive the car. For example, drowsiness, etc., can be detected. Mental health assessment and the assistive technology. It enables machines to understand human emotional states for better interaction. It improves user experience in gaming, virtual reality, and customer service. It is crucial for real-time monitoring in mental health and healthcare applications. Even in the classroom scenario, many times it is observed that how much is the student involved. There you can use basically the facial expression. Enhances in-vehicle safety by detecting driver fatigue, stress, or distraction. What is basically the drawbacks of the traditional method? Again, see, as even I have basically detected the facial expression, but the problem is that it needs good lighting to detect facial feature. In dim or dark environment, their performance drops significantly. IR cameras help out offer lower detail. Even see you can, they don't require the light, but they offer lower detail. Cameras struggle when parts of the face are covered. Then mask or hair can block important features, leading to inaccurate recognition. Capturing facial images or videos raises privacy issues, especially in public spaces or without consent. Variations in skin color, lightning, and expression intensity affect detection accuracy. Shadows and brightness changes often confuse algorithms. Quick and subtle facial movements are missed by camera due to limited resolution and frame rate. In that case, again, your wave radar provides a good way. The sunlight interferes with the infrared based depth sensors, making them unreliable outdoor. So that's why wave radar can detect fine grain because as we have seen it, able to detect the micro movements of facial muscles by measuring the phase and amplitude change in reflected EM waves. These subtle deformations, such as minor eyebrow lifts, lip tension, or cheek twitching, are crucial indicators of emotions, unlike cameras that rely on visual intensity or texture change. Radar directly measures physical motion even at the sub-mm level. See, that is the advantage. Traditional image-based systems suffer in poor lighting or when exposed to direct sunlight. MM-wave radar is independent of visible light and operate equally well in complete darkness, variable lighting, or glare-prone environment. This make it reliable for 24 by 7 operation, either in the indoor setting or in the outdoor setting. Also, we need to be aware that MMV radar does not capture images or video. Then it is not a privacy issue. So even see this has becomes valuable in sensitive environments, especially like the healthcare, transportation, or workplace monitoring, where users are not very comfortable with the camera-based tracking. Facial expressions are often primarily hidden by items like glasses, hair marks, or scars. MFB radar can still detect underlying muscular activity uh, beneath these obstructions because it reflects on the surface layers of the skin and even through light covering. It is able to pass through it and it will be reflected back. This enables accurate emotion detection without requiring a fully visible face. What we are seeing here, so in this scenario, the different emotions are shown there, that how the recognizing the different emotion is possible on a one page. So this is shown here. This is basically neutral expression. This is happiness expression. This is surprise. This is anger. This is sadness. This is fear. This is disgust. So when we took up it, see, we started with air facial expression. We have taken the balanced data set of this thing, that anger, smile, sad, surprise, neutral, 4,500. With the light GPM, we calculated as 90%, random forest 85%. So overall, then we are going basically towards the summary of application and benefits. Over to the MM-wave radar, it is basically offers the real-time processing. It is non-invasive, it is flexibility across domains. It is here, it is on the foggy roads, it is traffic monitoring, patient care, it is you are able to see land departure, uh, warning, all alert, facial access system. These are the traffic monitoring, patient care, vitals measurement directly that can be done. So these are the references from where we have uh, taken our work. Thank you. So this is the one. So here we conclude it. Thank you for your attention. Are you here? If you are here, then please respond by whatever favorite word you can respond. You are not machine. Whatever word you like it, please respond it in the chat box. Whatever your favorite word. No more any formality. Even this is my last. This is my also last session. It's a wonderful opportunity to interact with our family of DSP people who are interested in working. As Joshi sir told, it is always a matter of pleasure when you share the people which you enjoy. So definitely it's a very, very good opportunity for me. For me as well as my whole team, see, I am today, see whatever I am doing, see it's not only my work, only my research scholars, my students, they are extending the work. Whether it is the wave radar, this is primarily by the Anand. It's a biomedical images that is by the Suman. EEG thing that is by the Ramnivas. Face recognition that is by the Manisha. So it is a collective thing, what we are doing it. They are really extending the work in the best possible way. So please feel free to respond to your favorite word what you in the chat box. At least your presence will make the things very pleasant. Happiness, very good. So someone need to speak. Okay. Yes. So if others are also listening, then please respond. So I think maybe, hopefully, they are not here temporarily for some time. They would be there. So see, within some time, I asked Anand to demonstrate those devices which he has used in the hardware, wave radar as well as the ping ZU. So Anand, you
So this is the MWave radar which I have used to take the data like application of object, gesture, human activity recognition. It is visible. So this is the MWave radar in which this is the antenna, this is the USB cable by which we connect the computer laptop to this device, power supply, and by which we can take data like 3D point cloud image. And now this is the point cloud ping ZU board. Basically, this is a FPGA board we have used this device for validation for real-time application, in which there are many slot like this is a USB cable and this is a chip memory card in which this is used to store the data, and this is the light LED blink light. When we start the board, it blinks the light like white, red, green. There are many LEDs, and this is the switching board on off. USB cable board. So this is the device which we used to validate our work.
And how much time does it require to upload the whole program here?
How much time? It takes 1 to half an hour to process the data in PingZU board. Depends on application or data. Many feature extraction technique and machine learning will be implemented in this board.
Many times our machine usually hang up while running the deep learning program, ML program. Does it also happen with PingZU?
Actually, sir, till now we did not do deep learning programming in this, but future in which we will do next. So this is the device ML Web Radar, which we have used to take data. Visible?
That device is the hero of the last 4 hours.
Yes.
This ML radar, this is the one.
It is like sensor, camera, lidar, infrared. It works in all weather condition, lightning condition. It does not hurt the privacy.
So thank you. Actually, real hero is, that is basically the object. Real hero is the Anand, who is basically operating it. See, because it took the basically very much interest in using this device, and today whatever things we are able to do, the many things. Definitely, full credit to my team of research scholars. Thank you. See if you have any question. We are at AM Shah, if you have, I think other participants, I don't know whether are they here or not here. So one of the objectives of my workshop is to see not to basically when things become very difficult while doing mathematics, please use it in the application, like the devices. Small budget, this MM radar, it's around obvious 50,000, but research budget is available. If you have somehow you have chance. So these are the, I think, one of the key dimensions. So DSP is not only about doing the mathematics, but translating that mathematics into a real life observations using those devices. So that's I consider the advanced DSP, advanced interesting DSP. So regarding the last slide, what we have, what I've shared you here, if you notice it, it is basically enjoy peace by Sahaj Yoga meditation. See, many times, see, in our research is definitely one part, but to being in a research, as Suman shared, it is peace is required, and Shah has mentioned happiness. So definitely see this meditation, see different meditation techniques are there, but I am sharing this Sahajug meditation because I am practicing it. I really find it very useful because it is very less time taking and it is experiential. So if you have a chance to do that meditation, it is free, and the best thing, it is basically prevalent in the 186 countries. It is founded by Dr. Nirmala Srivastava. And because see, being a researcher requires a really very peaceful mind, very stable mind. Not only research, see, even when you are teaching to the others, even when you are doing research, teaching, if you are at sea peace with yourself, you will do wonders. I'm telling you. Being the same person, it really changes the world. Being in a state of happiness, you feel it that I want to give the more and more to my students. I want to learn more and more. So these things are there. That's why if you find chance anytime, please explore this one, this Sahaj Yoga meditation. Because today it's almost my final session. In the next three sessions, another is which is free, which you can experience. Today test basically it is test is you it is half an hour. It is half an hour test. You can give anytime till tomorrow. Till tomorrow 12 noon, you can select out any schedule, and in that half an hour you can give it. Link, I think it is on the
Uploaded on Canvas.
It has been uploaded on Canva, where you are finding out the your study material. So just
हमेशा नहीं है ग्रुप में से ऐड करना सर आई एम नॉट व्हाट्सएप ग्रुप
also you are also not on Canvas. So
I will add Amit Shah. Okay, today I will add.
better you know either you take the number of Anand.
Yes.
Right.
ठीक है तो उनका नंबर देना अमित शाह का नंबर मैं भी कर देता हूँ
ठीक कर ले. So thank you. So if others are not here, so it's thank you all.